Thank you. I didn't hear that.
I told you that.
So I would get this as my solution. So a lot of it is just stuff that we've forgotten in a while. So I'll probably do one yes, one no. So this one right here says a function f has a property that's sufficiently close, so approximately, right? X approximates to something to 4, right? But not 4, right? So we're saying the limit, right? Because it gets really close, but we're not saying f of 4, okay? The values get closer, so the f of x, right? So the y's get super close to -1. So what statement's true? Just kidding, I didn't screenshot the multiple choice. Pretty much what I'm saying is this. The limit as x goes to 4, right? Because that's what they told me, of f of x gets closer and closer to -1. And that's the definition of a limit. The limit as x approaches c for some function is the limit. Okay.
Wait, hang on. I was going to screenshot that one.
Okay.
Okay. Go ahead.
So this one right here, guys, it's not that bad. It says the limit is approaching 2. So remember, you have to check the left and the right. So when this right here, this is 2, right? We have to check on a number line. This is 2. The left would be when x is less than 2, and the right would be when x is greater than 2. So on this one, between 0 and 2, this will be my left. From 2 to 8, this would be my right. So all you have to do is substitute x equals 2 into both of these, the left and the right. So I'm just trying to provide little hints so you guys can do this mostly on your own. But of course, you guys can email me, text me, whatever the case may be, and I'll help you out. If you want me to continue, guys, please just unmute yourself or text it in the chat box and I'll continue it. But hopefully these are not that bad.
Are these even the questions from Calcmedic?
Yes, these are exactly the questions from Calcmedic.
Or you're just going over it?
Yeah, I'm just trying to like help you little reminders. But they do have a video first. They have a video and they say, hey, watch this video. I believe most of them, they try to do 7 minutes each video. And they cover a lot of topics. The next one, remember, whenever we have a limit that we can't really, I mean, we know how to do L'Hopital's rule, but without using L'Hopital's rule, the other method to finding limits was factoring. Do you guys remember that? Factoring. So we would factor these. So, it looks like this one, we can factor to be x outside, x plus 3. And then if we factor this one, it looks like I can factor negative k x plus 3. And we factor this one more time, we see that these are in common. So I got x plus 3 factored, and whatever's left over is x minus k. And then we divide it because it was being divided originally. And we factor it one more time. And this looks like it's gonna be a difference of squares, so x minus k and x plus k. This is difference of squares. And you go to see that, sorry, my k's look very like x's, right? And you get to see that my top, this one, and this one are the same, so I can go ahead and get rid of them. And then I just substitute k, right? Substitute k. So it looks like what? This one right here would be my answer. Because it would be k plus 3 on the numerator and k plus k on the denominator. Any questions on that?
No.
This one's an intermediate value theorem, guys. So I'll just, this is called IVT. Says that if you have a value, if you have a value right here, A, right? Let's call this at A. Okay, screw it. This is A, and this is B, and I'll say this is here. And these are random y values. Let's say this y is here, and this y2 is here. What can we say about this continuous function? So the intermediate value theorem says that if one is negative, one y is negative, and one is positive, there must mean there is a point C, right? That where the height is 0, where the f of c is equal to 0. So that is all you need to know for this, the intermediate value theorem. And guys, I am working on this little worksheet that has just like the theorems, what they stand out. If you see this word like triggered, you should be thinking of derive it once or derive it twice. Like example, if you see concavity, like your mind should be like, oh snap, that's second derivative or something like that. So I am working on that. I should have it ready by Monday, okay? And the mock exam, I'll post it today so you guys can see it, and then we'll work on it on Friday, right? Today's Wednesday. Yeah, today's Wednesday. Okay. This one right here, there's 3 conditions.
Oh my goodness, you're going a little too fast.
Oh, sorry about that, Albert.
It's fine. I'll ask you what to go over after this anyway.
Yeah, and the video that they make, guys, they mostly talk about it, so like I'm not trying to eat up too much time. That's the other thing. So what do we remember about the 3 conditions of continuity? There must exist an f of x, right?
Yeah.
That is equal to the limit of f of x. What else, guys? Do you guys remember?
F of x equals C? No.
The limit has to exist. The limit from C up has to equal to the limit as x approaches. C from the left, right? Left and right need to exist. One last thing.
Something's supposed to be equals to C.
Yeah. Yeah, so you have to be able to find out that f of c exists. Yeah, f of c exists, is a value, right? Yeah, so these are the 3 conditions. So you're pretty much saying that, hey, there's a left, there's a right, there's a value, right, at c. And guess what? The height is exactly at that point. So no matter what, like let's present that, this is gonna be, if I zoom out, it's gonna be like that. It is continuous. So you're pretty much finding that there. Using a table, guys, these look very scary, but honestly, they're not that bad. They're saying that this is the x values, right? This is the y values of these functions, f of x and g of x. And they're asking you to find h of x when it goes to 0. So this right here, we're going to find out where is 0, right? So if you see all of these are negative and all of these are positive, so 0 has to be right here. So in reality, we're going to check what is the values that go right here. So from here to here, what's in the middle? Well, I would like to say that it is 5. And right here between this number and this number, one is negative, one is positive. So IVT tells that the value would be 0. So we're doing that. F of x at 0 would be 5 times my g, which would be 0 minus 2. So in reality, this would be the solution here. limit as x goes to 0 for the function h of x is equal to -2.
5 times 0 equals negative. Wait, what? 5 times 0 equals 0 minus 2 because of the.
Yeah, because remember this is f of x, and the 0 is where we're going to. It's the number in the middle, and the other number in the middle for g, using this equation, -2 is what I did.
Okay.
This one right here, it's not that bad either, but it does take you a little bit of time to think. So it says horizontal asymptotes. It has a horizontal asymptote here and a vertical asymptote here. So what I told my pre-calc kids, and hopefully you guys remember it last year, x-intercepts come from the numerator, holes, and vertical asymptotes. I don't know if you guys remember this from last year. Whenever you factor something, a function, if you have the same factor in the same numerator and denominator, they're holes. The remaining factor is vertical asymptote. So this right here tells us there is a vertical asymptote at c minus x. Okay, so if c minus x equals 6, we're going to find out this right here. And then the horizontal asymptote is found by the degree. So horizontal asymptote, as we go to very, very high numbers, right, it's going to reach this y equals -6. So pretty much right here. So as it goes to negative infinity or positive infinity, the function goes to -6. So we're going to check the degrees of these two, just like in the first example. So the first degree is negative bx, right, for the largest degree in the numerator. The largest one is negative x. So I'm left with just b, because these were both negative. It's -6, so b is -6.
I got lost. What?
So horizontal asymptote, no matter how far left or how far right you go on a function. So here they tell us that negative infinity or positive infinity, it will both go to the horizontal asymptote, which in this case is -6. So our y is -6. The limit as x goes to infinities, positive or negative, would be -6. Because our function cannot go higher or lower than this -6. Because it's a horizontal asymptote.
Okay.
Okay. Next, it says that the other part has to be, remember vertical asymptotes? We can divide by any number except what? How do we create a vertical asymptote? When we divide by 0, right? So we're gonna look at this right here. Here's where I messed up. This should have been 0 because we can't divide by 0. So, and then we go ahead and solve for what they're telling us. So we're solving for this value c. So in this case, c would be what? Solving for this would be c equals x, which would be our 6, right? Vertical asymptote. Yeah, with c equals 6. So we just add the -6 and the +6, which would be 0. Okay.
Wait.
Yes, sorry. Got it?
C minus x equals 0, c of x, and then out of nowhere you just put -6, and then it's 0.
Yeah, because we found this
What?
one for b, and this right here is what came from this, which they said x equals 6. So I just substituted. So c equals 6. And then they asked us to add them together. That's where I got -6 plus 6, B plus C.
Oh, okay. Yes.
Okay. This one's not that bad, guys. It's saying the function as it approaches C, when does the limit equal 4? I'm sorry, how many times? How many times? Sorry about that. How many possible values? So when does it, how many limits are there? So it's not that bad. This one is an identity, or you guys know L'Hopital's rule, right? So whichever one you want to go ahead and do, because if we substitute 0, it gives us 0/0, right? So that means I can use L'Hopital's rule. So that's the way I did it, since that we know the identity tells us it's 1, but if you just want to find that out, we derive the top, it's 1, and we derive sine, gives us cosine of x. And the limit, we try it again, once it goes to 0. So 1 over cosine of 0 gives us 1 over 1. And they do have a free response. I'll talk about it real quick, but pretty much this one is self-graded, so you can just go ahead and see it, since, and then you click next and you check your work. And it has way nicer steps than what this is. So it gives us a graph for f, it gives us a table for g, and h is this function. And this is just info that tells you about what I just said. Okay. So for the first part, they want to find out which each of these values here, which one is not continuous of g of x. So g of x is this right here, all of this piecewise. So which one is not continuous? I'm sorry, yes. Oh, no, determine if it is or it is not at these given values. So all you have to do for a is substitute these values. A equals -4, and think, which one does -4 go into if we're given this piecewise function? So for f of a, you check f of x. So let's do f of x here at -4. Is the function continuous here? Does the left meet the right? No, right? Because there's a jump. So for sure, this one does not work. And then you have to say, oh, because the left-hand side, the right-hand side do not meet the continuity theorem. And then you do it for the second one, a -2, and you check -2. Is this continuous? Well, the left meets the right, but the function, there's a hole, so it does not. So that's pretty much how you do that one. For part B, it says, can you find the jk that j of x that is continuous at x equals 1? Well, we check. For x equals 1, it looks like we're using this one and this one, because x equals 1. This will be my left, this will be my right. So I'm going to use g of x, right? Because it says g of x at 1. G of x at x equals 1. My g of x is equal to 1. So this is my left. My right can be found from the function h of k, which is this one. Which says, sorry, it's a little too small. Let me go ahead and write it. H of x equals x ln of x plus k. And we substitute x equals 1. So it's 1 ln of 1 plus k. This is my right. So all we have to do, guys, is substitute the left and check if it equals the right. So on the left, we said that it was 1 equals the right, which we said it was all this good stuff, ln of 1 plus k. So 1 equals ln of 1, which is 0 plus k. So my k is 1. I know I'm racing through it, but it's just to help us guide us through the actual thing. The video itself that they are doing helps out also. So this would be our solution. And the last piece for this, it says interpret this limit. So as x goes to infinity, so we check which one is talking about x going to infinity from these three piecewise functions. Well, when x is greater than 1, I look at this function, h of x. So h of x, when it's greater than 1, talks about x, ln of x plus k. And I substitute x going to infinity. So hopefully you see that this is infinity and this is ln of infinity. It's just going to be going really, really large. And this is just adding to the infinities, which we know is 1, right? So all of this is going to infinity. Well, some sort of infinity, right? So we use this function, and it's in terms of j of x. So if this is going to infinity, and it's inside the piecewise function of j of x, j of x we can say is also going to infinity. And we can interpret this, we can say k of x approaches infinity. Therefore, um, j of x approaches infinity also. And then you can go ahead and check this because they give you the entire rubric to grade yourself on how you did. And they do this for every section. So I know I went a little too fast on this, guys, but it's mostly like you at your own pace. There's no penalties. You like, it doesn't give me a grade. It just tells me, hey, student completed it. So it's not for a grade. It's just for me to like tell you guys, hey guys, I guess, well, these would be compared to like little crash courses.